Graphing with data, spreadsheet down here. Is it working? There we go. So what should we have? Maybe year and maybe population. Some of you did exponential stuff. So I'll kind of demonstrate it with one of the harder functions or models, and then you can apply it to whatever model you've got. I'm also going to do that thing where we shift the reference for years. So year 0 I'm going to start with. Okay, so I'm just going to make up some data. Year 0 here, year 5, year 7, year 8, year 12, and I'll put in some numbers. The starting population, let's say 2 million for a country or something, I'm not sure. Let's have a look at 17 million, 54, 64, 78, and 156. Okay, so just random numbers. You should know this next bit. Document, insert, and it's not a graph we want, it's a data and statistics. Okay, we will, though, in this video, be looking at the graph page, because that's how I got the intersecting lines on the graph page. All right, so data and stats. Click, choose your variable, year, independent variable, and the dependent variable, the population depends on the year. Oh, beautiful. That looks pretty good, doesn't it? So I'm feeling an exponential model here because I'm seeing that percentage change each year. I'm not seeing the population going up by 500,000, 500,000, 500,000. Population change tends to be, if there's more people in a population, the population will grow quicker. Think about it. 1 million people in a population, maybe there's a reproduction rate of 10%. The population grows. But now in the next year, if the reproduction rate is still 10%, there's more people to find the 10% of. It's just what we did yesterday in terms of the population of the class. Okay. Let me finish the video, then I'll take questions at the end. Okay. And now fitting a model. Now most people do this: menu, analyze, regression, and exponential. Okay, that's pretty good. And when you look at the structure of this, 2.67999, and in the bracket 1.46. What does 1.46 mean?
It means that the original number will multiply by 1.5, so it'll be higher.
Okay, and so specifically in terms of percentage, what does 1.46 mean?
150.
Yep, 150% of the previous amount. It's a 50% increase or a 46% increase. So what the calculator's found for me, it's found the best growth model, exponential model, and it's telling me that these numbers fit a certain pattern where each year, because that was a time period, each X value, each 1 year, the population grows by 46%. Okay, so that's a real life application of that model. That's why that model is chosen, because it looks like it's a percentage growth model. I could have chosen a cubic, a quartic, but you don't get the same kind of connection and meaning there. But as I said to you before, if you've done that, it's absolutely fine for this first one. Okay, so now I'd like to put on some lines and find them intersecting. Now you can draw on here, but it's not so good. Menu, plot, let me see, plot properties, actions, oh, analyze, I've got there eventually, plot function. But all the intersection points on here are quite hard to find. There's a limited menu to do with intersections on this graphing page. This is just data and getting a visual. So better to actually then, I'll press escape to go back, better to draw a functions page, but it's even better than that. Ready? Go back to 1.1, which is my spreadsheet. On this page, here's a new feature: menu, statistics, statistical calculations, and you've got all your regression there. Exponential regression, click. What's the X list? Is year. The Y list is population. And look, save regression equation to F1. So you don't have to type it in yourself into the function plotter. It will save it automatically and plot it for you. Click OK. Over here is, let me just cancel that. Over here are the numbers. Look at the B, 1.46. Look at the A, And the model is a times b to the power of x. The little hat thing, the little carrot, is exponential, power of, okay? So those are your numbers. Further down, it's pretty cool because many people will probably know that this R number, this talks about a correlation coefficient. The closer the R value is to 1, the better the model fits the data. Figures of around 0.7 to 1 means strong correlation. This is a good, strong model. It means you can make quite accurate predictions from it. Okay? You guys probably try to work out percentage errors maybe for your project. Brilliant. So now let's try it. Doc, insert, graph. Okay? Now there's f2 of x. Click on the up arrow. There's f1 of x already stored. And now click on the tick here. And it will plot it if I press enter. It's plotted it. So when you see the graph, it shouldn't be a surprise because look here. When x equals 0, substitute x is 0 in here. 1.46 to the 0. 1. Anything to the exponent 0 is 1. And then 1 times by the 2.68. Now just thinking if I had this axis as 2.68 million, I'd have had to change the scale here. But now the 2.68, I'm thinking stands for 2.68 million. So that's quite a nice adjustment. So there's the graph. You can double click on the numbers and change the scale automatically from there. Double click on the numbers and change the scale. Or you can go menu, window zoom, window settings, and just go through all the x and y values there. Okay? And now we want to know after how many years will it be until the population becomes a certain amount. So we want to solve an exponential equation. Yesterday I introduced the language of logarithm, but we don't really need that if we've got technology, because here, menu, graph entry, function, f2 of x equals 30, gets us a horizontal line. So that would be my population reaching 30 million. And you can see it's about here, however many years this is. Menu, analyze graph, intersection. On the bottom left of the screen it says lower bound. The calculator is programmed to do some kind of iterative search. It basically bounces up and down between the two functions from a starting point until it finds the intersection. So you have to tell the calculator where to search. A lower bound and an upper bound. Search between these 2 points, please. So lower bound, click, upper bound after it, and there it is. So after 6.35 years, my population will grow from here up to 30 million. Is that good for everyone? You can also draw a vertical line just as a visual, which is kind of nice. Menu, graph entry. Instead of function, which only allows you to do f of x equals, so that's y equals, you can go down here and look at an equation template. And on the line, you can see a x equals c, x equals 3, x equals 4, vertical line. So I'm going to type in x equals 6.28. Oh, 6.35. If you want to change it, I can just double click on it. That's pretty cool. Anything else from here while I'm still videoing? All good? Fabulous. Okay,